Let's pick up this lesson 10 at question 7. So this is the part 2. And go through it. So now we want the inverse function of this given function. And this is a cube root, which is the same thing as x to the 1/3 power. Okay, so to undo a cube root, we're going to need to cube it to a 1/3 power, right? So let's go ahead and set this up. So this is, we start with y equals 12 plus the cube root of x. First step, change the x and y, so y becomes x, x becomes y. Cube root of y. Now we want to solve for y. So we isolate the cube root, subtracting 12 from both sides. Come over here, so this is x minus 12 equals cube root of y. And to the inverse of a cube root is a cube, a 1/3 power. So we take each side to the 1/3 power. These two are inverses, so they cancel each other out. Y is now equal to x minus 12, all raised to the 1/3 power. So that's what goes up here, and we'll just click on the answer and we'll see that it's x minus 12 to the 1/3 power, x minus 12 to the 1/3 power. Okay. So now it looks like we're getting into cubing, so this kind of a polynomial rather than a square, a quadratic. Use algebra to find the inverse of this function. And you're going to see with a cube, because there are, right, 3 powers, you can have negatives inside of a cube root. So actually, well, we don't need to restrict it. Partly, we didn't do this, but if you graph a cube root, you'll see it graphs something like this S-curve. It's not a very good one. So, but you'll see it passes the horizontal line test as well as the vertical line test. So we don't have to restrict the domain, if that makes sense, hopefully. Okay, so this one, again, we're just going to write it as y equals negative 3x to the 3rd minus 6. And kind of get this stuff out of the way. So we want to isolate, first step, first step, change the y and the x. So y becomes x, x becomes y. That's the inverse step. That's what the inverse does. Now we solve for y. Okay, so we're going to add 6 to both sides. We end up with x plus 6 equals negative 3 y cubed. Divide both sides by negative 3. So that cancels with that. Divide this side by negative 3. Now you could bring the negative up here and make this negative x minus 6, or just leave it down here. And just to save us some room, so we've just got y to the 3rd power left, what we want to do, what undoes a 3rd power, is a cube root. Take the cube root of both sides. So a cube root cancels out a cube, so we're left with, this is what y equals, and that would go in here, right? Cube root of x plus 6 over negative 3. We'll check the answer and you'll see that. Again, you could bring this negative up and have it negative x minus 6 over positive 3, however you want to do it, but I like to leave it as simple as possible, and they did see, they say both. So the cube root or the 1/3 power, they left the negative 3 down in the denominator. So either version will work. Answer like this, type root in x, so again, maybe I'll show you that take this out, but let's see, how would we type it in? We would type in this one. I think that's easier than using their things. We're going to put this to the third, and then inside we can get a fraction, x plus 6 or negative 3. And that's how we would enter it. That's how I, use the little tools. And you can type this in, but so there's sort of two types of way of more programming or coding, or just use their functions. We've got all these different basic things that take care of it for you. All right, question 8. Now let's go on to 9. Domain of composite functions. So a composite function is one function, as you can kind of see here, getting plugged into becoming the input of the other function. Now there's two things we have to check. We have to first check the domain of the function that is being inputted. So the input function, because x goes in here first. So for this first part, we'll call this A, we'll call this B. So for the A function, we need to look at the function, what we put in for x first, but we also need to look at the end result. Do we need to restrict further? Okay. So the first thing is we look at, since g of x is going in, to determine its domain, we go square root of x plus 2. What would be its domain? Well, it's in a square root, so we need x plus 2 to be greater than or equal to 0. Subtract 2 from both sides. We need x to be greater than or equal to negative 2. Now, the other thing we need to check is once we plug it in, is there an additional restriction? So g of x getting plugged into f of x. So we take the f of x function, which is going to receive, this function is going to go plugged in for x. So I like to write this as f of g of x, take the f function and replace the x with a big open parentheses, because that's where g is going to go. So this is x plus 1. Just x is now a big parentheses. Inside there is going to go the g function. And we can see, if we look at this domain, it's really the same thing. We have the same issue, what's in the square root. So the domain here is simply going to be x has to be greater than or equal to negative 2, which means negative 2 to infinity. I guess I could put it in there. We'll already go ahead and check, right? Now, if we switch the order that we're putting in, we've got to look at the f of x first, and then we look at the end result. So if we look at f of x, x plus 1, so that's the input function. It has no problems. There's no square root. There's no division by 0. So this is negative infinity to infinity. However, we also have to look at what happens after the output. So we're putting g or f into g. G is going to be the receiving function. So we're going to write the g function, which is the square root of x plus 2. And what is x? We're going to plug in f of x, which is green, right? X plus 1, that gets put into here. And so we don't really need these parentheses. We can take 1 plus 2. It's going to be the square root of x plus 3. Now this is the end result of this composition. We are going to have a different domain. We've got to take the inside part, that x plus 3 has to be greater than or equal to 0. Otherwise we get imaginary numbers. Subtract the 3, x has to be greater than or equal to negative 3, not negative 2 now. So our domain here is x is negative 3 or bigger. Okay, so see how that works. We We checked the input function and it had no problems, it's everything, but by the time we get to the output function, we have to restrict the domain. The domain gets restricted because we don't allow for imaginary answers. Okay. Question 10, find the domain for each of the following functions. Okay, and remember, here we are. Let's go with blue this time. The two things whenever we're talking about domain, we have problems when we divide by 0 or negatives inside of a square root, not a cube root, a square root. Okay, so first one, that's our issue, is if the denominator becomes 0, we will have a problem. So we say, what makes 4x plus 1 plus 11, what makes that equal to 0? We need to remove that from the domain. Okay, subtract 11. So 4x, 0, right, equals negative 11, divide by 4. And this one, we need to use exact values, so we cannot put in a decimal. Okay, we need to put in a fraction, but that's okay, we'll be okay. X equals negative 11 fourths. So that's the number we need to take out. We need to remove it, negative 11 fourths. Which means we can have all the numbers to negative infinity, all the numbers to positive infinity, put it plus, but we can't have this one. So we type that one in there as, let's see, parentheses, where there's our infinity to negative 11 fourths. So see how I did that? 11 fourths, yeah. Union, let's see, do we have the union key? We don't here. How about for intervals? This is even better. It's got all our stuff here. It's got our union, and then we know this one is also going to be open like that. And then we go back to basic. Negative 11 fourths. Can do it this way. It'll be the same. Arrow over, comma. Then we need our infinity, positive infinity. Oops. Now that I said that, this should be a negative infinity, not just an infinity. So that should work. Negative infinity, negative this. So yeah, we work out. Okay. It's the same thing, 4x plus 11, so actually the solution is going to look very similar, except with the square root, 4x plus 11 has to be greater than or equal to 0. It actually can be equal to 0, but it can't be negative, right? So we solve it with an inequality, subtract 11, we're going to see we get the same, negative 11 fourths. 4, cancel, x has to be greater than or equal to negative 11 fourths. So here's 11 fourths, negative 11 fourths. Let's change colors. We can include it, but also x has to be bigger than this. So we go all the way this way. We don't go in the other direction to positive infinity. So this one, let me just write it, negative 11 fourths, and this one's going to be a bracket because it is included to infinity. And again, we just check our answer. Yeah, we're doing good. We're doing good. A few more. I think we've got 4 more questions, or maybe 3 more. Solve the following inequality and graph the solution. Now, what we're going to do is the way, because this is factored, whenever one of the factors becomes 0, the whole side becomes 0. So we can find where it's equal to 0. And then what we're going to do is we're going to check the point. So let me explain here. So what we really do is we take x minus 7 times x minus 3. We solve for where it's equal to 0. So that's going to be when x minus 7 equals 0, or when x minus 3 equals 0. You kind of see it's the opposite, right? If I put a positive 7 here, positive 7 minus 7 is 0. And we do that by solving as well. When x equals positive 7, we're here, add 3 to both sides. When x equals positive 3, those are going to be the two places we get equal to 0. So what we do is we do a number line. So here's x equals positive 3. Here's x equals positive 7. And we're looking for where we get values that are greater than 0. So it means positive numbers, right? Well, we know we get them equal to 0 here. So 3 and 7 are actually not included. We want to see what about a number, one of the easiest ones to choose. What about this number over here, 0? Because whatever happens on here, it's either always going to be positive or always going to be negative. Remember, a graph it'll pass through the zeros here. This is a graph. Or it'll be above. So what happens at 0? So 0 minus 7, 0 minus 3, is that greater than 0? So this is a question. We get negative 7, right? 0 minus 7 is still negative 7 times negative 3. A negative times a negative is positive. It is greater than 0. Yeah, that's positive 21. Yes. So on this side, to the left side of 3, so at 3 it's not included, but to the left side this is all going to be positive. So so choose test values and indicate whether the inequality is true or false in each region. Enter the test values from the smallest to the larger. So I used a test value of 0. Okay, so they got us going here. I'm going to draw the solution above. So again, come here, give us a nice, so 3 and 7 are open circles, right? Those are not included. We just did it. We tested 0, so I'm going to go this way. Is included. So let's continue here. Actually, I should probably put 0 I tested, and then what we're said, it's true here. Now we choose a number between 3 and 7, and we can plug that in. My gut feeling is it probably won't work here, but let's do that. Let's see what's a good number to choose. I guess 5, it's in the middle. Again, we could choose any of these. So we get 5 minus 7, 5 minus 3. 5 minus 7 is negative 2. 5 minus 3 is positive 2. And that gives us a negative 4, which is not greater than 0. So this one doesn't work. And again, we could have chose any one of these. We could have chose 4 or 6 or 5.5 for that matter. We'll just put that in that it's false. Okay, so it doesn't work here. And then we choose one more that's bigger than 7. And you choose any, maybe 10. I don't know, it's a nice round number. And what we do is we plug in 10 to the formula up here. So we get 10 minus 7. We get 10 minus 3. Now you can just see both of these are going to be positive, right? 10 minus 7 is positive 3. 10 minus 3 is positive 7. And yes, that's going to be bigger than 0. It's 21. We don't really care what it is. We just know it's positive. I mean, the amount, we just know that it's a positive value. So what I can do is here, I can say we checked 10. And that is true. So we come back to our little tools here. And we say we get to go this way. So that's our solution. Got that part. Got everything going for 11 here. And then the interval notation, right? Negative infinity to 3, union 7 to infinity, with the 3 and the 7 not included. So let's go ahead and that in there. So negative infinity until 3, not including 3. Come over to interval. We're going to union that with positive 7 to infinity. And we see that's correct. In fact, let's just check our answer. It's going to mess things up. So we get marks here. And again, we could have put in any numbers we wanted as long as we were in the right intervals. Likes everything that we did. Okay, so that's how we can do an inequality. We're going to look at another one. And this one's going to be a little bit more challenging because we aren't given it in factored form. So we'll do the same thing, but we need to factor this first. So 30, there's numbers that multiply to be 30. There's 3 times 10. There's 1 times 30. There's also 5 times 6. Since there's a negative in front, that means we're going to subtract the two numbers. And when we subtract those two numbers, we need to get a positive 1. Well, 5 minus 6 is 1, so we'll go with this one. 3 minus 10 is 7, so that's not what we have in the middle, so we wouldn't use that one or the other ones. So let's try this factoring. So x and x gives us x squared. We've got 5 and 6. We know we're going to subtract, so that means the signs are opposite. And we know that the end result is going to be positive, so the bigger number has to be positive. That means that this one has to be negative. Negative 5 times 6 gives us negative 30. Okay, and we want this to be where it's less than 0. Okay, now they don't have all the intermediate steps, but we will do the same thing we did on the last one. We're going to solve for where they're equal to 0. So x minus 5 equals 0, or x plus 6 equals 0. This one we add 5 to both sides. X equals 5. This one we subtract 6 from both sides. X equals negative 6. So that's our number line. Here's 5. Here's negative 6. It does not have the equal to, so these two are open circles. They're not included. And then we test these regions. I always like to, wherever there's 0, so 0 is somewhere between here, maybe a little bit closer to the 5. 0 is always a nice one to check. And then we check one less than negative 6. And again, you could choose any number over here. Maybe we'll go with negative 10 and 5. Maybe go with positive 10. Again, you could use any number. Could have checked 6, or just we've got those are the regions we're going to check. So what I'll do is I'll put in negative 10 up here. So we get negative 10 minus 5. Right, that's going to be negative. Negative 10 plus 6, that's going to be negative. Is that going to be less than 0? Well, no. This gives us negative 15. This gives us negative 4. Negative times a negative is positive, so this is, no, this is false. We get a positive number. And again, it's not, what is it, 60 or something. It's not so important what the value is, but that it is a positive value. So it does not fulfill this. So this region is not included. Probably is going to be this one. Okay, so we put in a 0. 0 minus 5 times 0 plus 6. Is that less than 0? Well, yes, plus 6. We get negative 5 times positive 6 is going to give us a negative 30. Again, it's not so much the value, but that it is negative. That makes it less than 0. So this region is included. All of this is in there. And you'll see you could try this one, but it's not going to work. You put in 10, you get 10 minus 5. That's going to be a positive number. Oh, actually it might work. Oh, no, we need it to be less than 0, right? We need it to be negative. So that's not going to work. And then we get 10 plus 6. Is that less than 0? So it's always checking the thing. So we get 5 times 16. It's going to be a positive number, so this does not work. So this is our interval. We're going to go from simply -6 to 5, and that's it. There it is. Okay. And I think this is our last question, and notice we have basically, we're going to get 3 intervals. So as you go through this, maybe I'll do this in a sort of a shorthand method. We're going to get a 0 from this. That's going to give us -5, right? It's always the opposite sign. -5 plus 5 is 0. This will give us a -1. -1 plus 1 is 0. And this will give us a +7. So those are the 3 places. Didn't have to sort of do all the work. We're seeing what's happening. -2 doesn't really matter, although when we do our check it will matter, right? Because it's a negative, and we're looking for this to be less than or equal to 0. We're looking for it negative or 0. So the endpoints actually are, in this case, going to be equal or included. So what I do is I draw my number line. Got -5, -1, and 7. So put -5 about here, -1's about here, and then 7's maybe like here. And then I go back and feel, okay, where am I going to check? I always like to use 0 no matter what. So 0's here. When I check this region, I need to check a region here between -5 and -1. Again, you can choose any number you want. How about -3? And then we need one less than -5. Again, anything you want. You could do -6. Let's just check -6. And then we need to check the region that's bigger than 7. 8. Why not? And again, you could have chose 10, whatever numbers you want to work easily with. And then what we're going to do is we're going to plug each of these green numbers into the function and see if it's true or false. I'm going to start with 0 because that's always the easiest one. So 0, 0, 0 gives us -2. Now this one we have to leave this -2 in here. It doesn't have an x next to it, so it doesn't give us a boundary point, but we're taking -2. Plug in 0, we get a +5. Plug in 0, we get a +1. Plug in 0, we get a -7. We get positive, but we get 2 negatives, so this is going to be positive, which is not less than or equal to 0. Okay, so this region is, the region of 0 is not included. I'm just going to put a no. So as you see these, it's kind of, my suspicion is that it between -5 to -1 is included, and then from 7 on. So if this is not included, the next door regions are probably going to be included, because how do we get from 0 to that one? Now, it's always possible that they're not, because the graph could have come down and touched the graph, but we know all of these, thinking back to some of the other things, that they have a multiplicity of 1, so they go straight through, thinking about how things work. But let's go ahead. We'll plug in -3 next. Again, my thing is we're going to get a yes here and a yes greater than 7. So let's plug in -3. So we get -2. -3 plus 5 is going to give us a +2. -3 plus 1 is going to give us a -2. And then -3 minus 7 is going to give us a -10. Again, I don't really care so much about multiplying this out, but we get a negative times a negative, that's a positive, so those two together, and of course times that positive, we get a positive, but then we got this negative. It's going to be a negative number, which is less than 0, so when we plug in -3, this is part of the solution. This is going to give us a part of the graph that's less than 0. Okay, we check this one, that doesn't work, so we're going to check 8. And again, I come over here, I get my -2, +8, sorry, check +8. 8 plus 5 is 13. 8 plus 1 is 9. 8 minus 7 is +1. Is that less than or equal to 0? Yes, we got a negative here. All the rest are positive, so this is going to be a negative number. So yes, everything here is included all the way, and once it's included, there's no other boundary. 7's included, and again, -5 is included, -1's included, and 7 is included. We can check -6, but just real quickly, that gives us a, I'll do it here, so we get a -2, a -1, -6 gives us what, negative something, -5, and -6 will give us another -13. So negative and negative is positive, negative makes it negative, negative, so this is positive, which is not less than, so this is a no, just like I thought. So we've got these two regions, and all we need to do is put in here our interval, which is listed on our number line. So we have a bracket. We go from -5 to -1, and then we union, and this will be a one-sided bracket, because when we go to infinity, we have a parentheses. Then we jump to 7 to infinity, positive infinity. Okay, we check on that. Oh, we look like we did good. So those are the homework, the quiz, the test. You'll see similar type questions in the homework, and again, they build from, you kind of use this, what's this one? Number 11 was sort of like a model of all the steps you want to go through, even though the question may just be asking for the interval. To get to there, take all those steps, and you'll be able to do it correctly. All right, thank you very much. Good luck on getting through lesson 10, and we'll have our work days